Welcome to our first part of the last section of our rationals unit, focused on proportions and cross products. So, couple of vocab stuff first. A ratio is a comparison of two values by division, usually written as a fraction. So, for example, 5 over 3, 3 over 5, x over 2, and 1 over x plus 3 are all considered ratios. They're just two values in a fraction being compared by division. A proportion is an equation of two ratios. So 3 over 8 equals 9 over 24, x over 5 equals 3 over 15, 2 over x plus 2 equals 4 over x plus 4 are all proportions. They all have a ratio set equal to a ratio. And then, gotta bring my camera down a little bit. Cross multiplication or cross products, which are definitely terms you've heard before, but some people kind of get them confused with other things. Cross multiplication is defined as if A over B equals C over D, then A times D equals B times C. So with the proportions that we've written so far, 3 over 8 equals 9 over 24 is the same thing as 3 times 24 equals 9 over 8, or 9 times 8, and we could do that math and see that that is true. Or if we're using variables, x over 5 equals 3 over 15, x times 15 equals 3 times 5, which gets us to 15x equals 15. We divide by 15 on both sides, we find that x equals 1. So this problem here is the same as the kinds of problems that you're going to see in the proportions and cross products delta math practice in the first section. So these ones are just using cross multiplication to find our value of x. Another one that looks pretty similar, it just has x in a different place, is negative 3 over 5 equals 15 over x. So cross multiply, negative 3 times x equals 5 times 15, which gets us 3x equals 75. We solve that like a regular equation, and we get x equals negative 25. I wanted to include this example because sometimes people think that the x has to be here, and that's just not true. Sometimes, though, we will have proportions with binomials in one or both of the ratios. When this happens, we have to distribute when we cross multiply. We have to distribute. So if we were given x plus 5 over 7 equals x plus 8 over 4, remember that these have parentheses around them, technically. We don't always write them that way, but they have parentheses around them. So when we multiply, we're multiplying 4 times the quantity of x plus 5, so I've written that here. And we multiply 7 times the quantity of x plus 8, so I've written that here. Now that we have a number outside of a set of parentheses, we distribute. So we get 4 times x is 4x, 4 times 5 is 20, equals 7 times x is 7x, and 7 times 8 is 56. So this problem that we're working on right now is very like the problems on the Delta Math Practice Section 2. So now that we have this equation, we solve it like any other equation. I'm kind of condensing two steps. So I'm moving the x term over here by subtracting 7x, and I'm moving the constants over here by subtracting 20. I just kind of did it all at once. We get 4x minus 7x is negative 3x, and 56 minus 20 is 36. To solve for x, we divide both sides by negative 3, and we get an answer of x equals negative 12. Now up here, we could probably plug this in and see that that's true pretty easily. We could, oh yeah, x equals negative 25, that makes sense here. This one might be a little bit more challenging to see that this is x equals negative 12. So if we're ever not sure of an answer, we can always check our work by actually going and plugging that in to the original equation. So if x equals negative 12, that means we're going to get negative 12 plus 5 over 7 equals negative 12 plus 8 over 4. We do that addition, we get negative 7 over 7 and negative 4 over 4, both of which are going to simplify to negative 1. And negative 1 equals negative 1, so that is good. Our answer is correct. And then the last of this particular kind. Sometimes when we cross multiply, we will get a variable squared. This is going to be the case in section 3 of the Delta Math proportions and cross multiplication practice. So if we had, for example, x over 5 equals 9 over 5x, when we cross multiply, x times 5x equals 5 times 9, ends up getting us 5x squared equals 45. But when this happens, we just solve it like any other quadratic equation, whether by factoring or by using square roots. In this case, I think we're going to want to use square roots. So 5x squared equals 45. Divide both sides by 5. We want to get the x squared by itself first, just like we would with a regular variable. So we divide both sides by 5. We get x squared equals 9. That's a nice one we can easily square root. So take the square root on both sides. The square root of x squared is just x, and then that equals the square root of 9, which is plus or minus 3, or positive or negative 3. So that one will end up with 2 answers, but wasn't that much harder than the others, I hope. And that is the basics of solving proportions with cross multiplication, and that is the subject of the first Delta Math practice that we're going to work on.